Hello, Algebra 2 people. What we're going to do in this video is just summarize everything that you saw this morning in that card sorting activity. We got the ideas of how these graphs work. What we're going to do now is really just put those ideas in writing. So we're on page 9 in the notes, taking a look at section 5.3, graphing polynomial functions in standard form. The first thing we need to talk about, end behavior, that last way that we hopefully sorted those cards this morning. End behavior tells us what's going on the left end of the graph and the right end of the graph. End behavior is all about what's going on at the left end of the graph. On the left side, is it pointing up or is it pointing down? And the right side. On the right side, is it pointing up or is it pointing down? End behavior is all about what is going on at the left end of our graph. Is it pointing up to the left or down to the left? And what's going on the right. I probably should make this consistent. The right end. Is it going up or going down of the graph? Please copy that down. So we saw when we did our sorting activity that end behavior is based on two things: the degree, the highest power, and the leading coefficient, that number out front. If the degree is even, and we have a positive leading coefficient, our end behavior will be up to the left and up to the right. For example, it might look something like this. I don't know, just making up some random graph. This is not necessarily the formula for the graph, but it's an example of a formula with an even degree and a positive leading coefficient. Y equals 2x to the 8th minus 3x to the 5th plus 4. Even degree, even highest power, and positive leading coefficient. We can also have an even degree and a negative leading coefficient. And that would be down to the left and down to the right. Might look like this. Y equals negative 7x to the 4th plus 2x minus 5. Could be an example of that. Even positive would go up and up, even negative, down and down. Even degree, negative leading coefficient. And when I ask you in a moment, here's some random polynomial function, what's the end behavior? You're going to tell me the end behavior in terms of those arrows. If I have an odd degree, but a positive leading coefficient, my end behavior is down to the left and up to the right. Something kind of like this, maybe. Like y equals 2x to the 5th minus x plus 1. Odd degree, positive leading coefficient, positive number out front. Our final type is an odd degree with a negative leading coefficient, and this would go up to the left and down to the right. Maybe something kind of like that. Y equals negative x to the 7th plus 6x. Odd power, negative number out front. Please make sure this chart is copied into your notes. So this chart will need to be memorized. But let me give you a couple hints for memorizing these things. It can kind of get us away from actually memorizing line for line in this chart, but really just kind of generalizing a couple rules. First of all, if the degree is even, both arrows are going in the same direction. either both up or both down. If the degree is odd, the arrows are going in opposite directions, one up, one down, one up, one down. If the degree is even, then both arrows go in the same direction. If the degree is even, both arrows are going in the same direction, either both up, both down. If the degree is odd, the arrows go in opposite directions. If the degree is odd, the arrows go in opposite directions, one up, one down. Then, if the leading coefficient is positive, like here and here, that function ends by pointing up. And if my leading coefficient is negative, my function ends by pointing down. If the leading coefficient is positive, the graph ends pointing up. And if the leading coefficient is negative, the graph ends pointing down. Take a moment, copy these hints in your notes, then I'll see how we can kind of use these hints to get everything we need from our table to deal with some problems. Okay, so looking at the next page, we want to try to find the end behavior of these various polynomial functions. That first one, y equals negative 2x to the fourth plus 3x. The only thing I care about is my leading term, so I'm going to focus on that. Now, we could use our chart and just match up what we see here with the lines there. Or if we want to try to use our shortcuts, I notice that the degree is even. That tells me they're both pointing in the same direction. Leading coefficient is leading coefficient is negative, which means I'm going to end by pointing down. And since the degree is even and they're going in the same direction, I'm going to start by pointing down. And I'm going to say that my end behavior is down and down. In letter B, my degree is even, same direction. Leading coefficient is positive, so I'm going to end by pointing up. If I end by pointing up and they're going in the same direction, then I'm going to start by pointing up. See if you can do C, D, E, and F. What's the answer to C? Even degree, positive leading coefficient, you're going up and up. What's the answer to D? Odd degree, so they're going in different directions. Positive leading coefficient, so you're going to end by going up. You're going to start by going down. Down to the left and up to the right. What's your answer for letter E? Not positive. Odd degree, so they're going in different directions. Negative leading coefficient, you're going to end by going down, which means you're going to start by going up and down. Letter F, what's your end behavior? Odd degree, negative leading coefficient, you're going to end by going down. You're going to go in different directions, so you're going to start by going up. When I ask you to tell me end behavior, I'm looking for answers with arrows like this. Next thing that we saw, we were able to pick out the Y-intercept on a lot of those functions. And we saw that the Y-intercept is really just the constant term at the end, just like for polynomial functions in standard form. To find the Y-intercept of a polynomial function, it's just going to be 0, C, where C is the constant at the end of the polynomial function. The constant term at the end. The y-intercept of a polynomial function is 0, c, where c is just the constant at the end of that polynomial function. Get that in your notes, please. So I want to try to find the coordinates. Don't just give me a number. I want coordinates of the y-intercept. Well, in letter A, the constant at the end is -1. So I'm going to say that my y-intercept is 0, -1. Try B. What are the coordinates of the y-intercept in B? Number at the end is 3, so my coordinates 0, 3. What are the coordinates of the y-intercept in C? There's no constant at the end, which means the constant at the end is really like a 0. So I'm going to say 0, 0. The other thing that we saw was, in general, as the degree gets higher, the graphs, in general, get a little bit more complicated. First of all, the maximum number of x-intercepts, which can also be called zeros, also can be called roots, that our polynomial function can have is just the degree. I'll call that n. At most, how many x-intercepts can we have? Well, whatever the degree of our polynomial function is. We also saw that the most number of times that it turns, that it changes direction, we can also call those places where it turns maximums or minimums. Remember, I would say that this graph turns direction in 2 places, and I would say I have a relative maximum and a relative minimum over there. The most number of turns is the degree -1. Or we can think of it as n minus 1 if n is the degree. So, if I give you a random function, we'd have no idea what it looks like. We just have this formula over here. Y equals 2x to the third plus 7x squared minus x plus 1. At most, how many x-intercepts will I have? At most, how many places could it cross the x-axis? Well, whatever the degree is. My degree is 3. There could be at most 3 x-intercepts. I might not have 3. I might only have 2 or 1. But I know I certainly can't have 4 or 5 or 10. 3 is the most I could have. Maximum number of turns. Well, the most number of times it can change direction, change from going up to going down or down to up, is the degree -1. 3 minus 1, I'm going to get 2. No, I don't have to see that calculation. You can just tell me 2. Take a look at the bottom one. Tell me the maximum number of x-intercepts. I think at most there are 5 x-intercepts over there. At most, how many turns? Degree -1, 5 minus 1. No, you don't have to write out that problem. You're just going to tell me 4. This is about all the analysis that we can do without using technology. To actually get a good graph of the function, though, we need to go to the graphing calculator. And when I see you in person, hopefully, I'm recording this on January 14th. I hope we're going to be back in person next week. Hopefully, Cohort B will learn about that on Thursday when I see them in person, and Cohort A on Monday when I see them in person. But we shall see. So this is all you're going to need to know for right now from section 5.3. Page 11 will fill in class when I actually see you back in the building.